I'm very happy to be here, and my name, as I said, is Björn Ekelund. I'm an architect and urban designer. I am a researcher, colleague with Agatino, but also the co-founder of the urban design office Warm Winter in Stockholm. To give some background on my presentation is basically to say that COVID-19 are about to rewrite the rules for the concept of density in urban design, increasing social footprints and increasing the need for public space. And now we're struggling to find our way back to what we are used to, or some of us are struggling to find a way forward to a change. And this change might be helpful or might benefit from the idea that there is the need for renewable energy. And that's basically what my project and presentation is about. But the concept of distancing in planning and urban design is not new. Distancing is what the industrial era has brought to the modernist urban planning and design paradigm during most of the 20th century. With increased technical solutions for energy production, sewage plants, waste management, power lines, commuting, etc. And all of this has been in the development idea of our modern infrastructure in distancing. And this has not been a problem. This has rather been a solution for economic growth, as being a means to an end. But this distancing comes with a price. And the price could simplified be described as a global sustainability battle between the two terms of effect versus efficiency. From a technical perspective, large-scale solutions located far away from people are more efficient. There's no question on that, thus creating a greater good. But from the point of understanding a transformational change, introducing new financial and local business opportunities, create greater robustness to disturbances, etc. Local solutions actually might have a greater effect, both on a social and on economic sustainability. And if this also means that sustainable infrastructure suddenly are adapted to make a greater footprint, such as public space, it also can increase the impact on ecological sustainability. So before COVID-19 and still, I worked on a number of projects to create reduced distancing between technology and humans. Instead of large-scale solutions, I would rather talk about all-scale solutions, finding the way through for implementing renewable energy production into any place possible, making it accessible for anyone possible. And it all started actually at my own university outside it. There's a quite big power line going through the area. And I realized how extremely non-place specific this power line is. It goes through a landscape, whether it's an urban landscape or natural landscape, without actually reacting to it. So my own starting point was how can I redesign a power line to react to a place specificness? And basically creating public spaces through the power line. So instead of an energy transmission, it was also a public space maker. And to make this, I used a technology called tensegrity, a construction technology that is. Tensegrity has all the components that an ordinary power line have. So basically, I never changed anything of the ordinary components. I have the distance, I have the power lines, and I had the poles, but I just reconfigured them. And reconfiguration of the existing elements can sometimes be quite helpful to understand new possibilities. So this also became one of the proposals for a competition on Iceland. It was also part of a larger exhibition in Europe for a couple of years. And this is the more in-depth study of tensegrity and power lines and how they actually could work from a more construction point of view. But the whole idea of this is still not the construction of the thing, power line and transmission. It's rather the construction of place. How can a construction be adaptive to a place and thus change its design? So a lot of the studies we have been doing in the early years, and with this I mean maybe 15 years ago, 10 years ago, was about the construction and how can construction contribute to place specificness. And this also led me into the idea of how can we create micro constructions of climate. Because I got an assignment at the office designing a wind power plant in Stockholm, on a campus area. And on this campus area, I realized that, okay, so there's going to be a wind power plant. A lot of the public space is going to be taken into use. And maybe not for a beneficial point of view, but from a sort of bad point of view. So what I did, I was actually trying to elaborate on, okay, if the wind power plant is basically focusing on production of energy and at the same time the production of public space, what would it look like then? Then I realized that the construction I needed to work on was actually the microclimate. So a lot of the design was about increasing the wind speed at the places I needed it and reducing the wind speed on the square where people should stay. So basically it came out as a wind square, moving with these moving wind turbines on this piezoelectric floor, with mixing with both with people and energy production, creating wind where it should be and creating calmness where it should be. Moving from technology and climate to microclimate, I've also started to work quite a lot with people. I realized that this is not a change that I do as an architect alone. It's not a change that any technological engineer would do on its own. It's a change that needs to happen from everyone. So me and Tino, as he already has explained a bit about, has been working quite a lot with people and their idea of energy production. What is it? Where can it be? And how can it be designed? And it's quite interesting and really, really fun if you start integrating people into the design process, because what happens is that they have fantastic ideas that you might never have come up with otherwise. And these ideas are something that we try to realize in the first kind of sketch design to the campus area of Piteå. So this actually quite intriguing combination of solar panels, water micro turbines, and some solar. Actually, the solar balls down to the right is to keep the water from freezing in the winter. So they actually had a great idea transforming their own campus from car parking space into energy production. And energy production allowed it to become a place to meet people, a place to look at, a place to be at, a place to have concerts at, and so on. So the idea is not about transforming one space to energy. It's about transforming one space to a better space through the introduction of energy. And this project actually led me to another design task that we had, and this is the last one. I know I'm going to be short. So, and this design task was on the same campus I just showed you, but it was on the outskirts of it. You see the rather big blue square in the northern part of the plan. It was planned for an energy production solar panel field, fenced off from the rest, but there was leftover space there that could be used for it. When I got the assignment, I said, okay, so you have a leftover space of nature. You want to fence it off and introduce a technological solution to it. Why don't you think the other way around? Instead of this being a leftover space, why don't create a public space, but with the introduction of solar panels? So, and I also knew that in this project, I would collaborate with two main research groups. I was the architect from Warm and Winter, but then we had two research groups. One on energy, which was super important in this case, and one on wood construction. The team on energy.
Sorry, let me know that 7 minutes have already gone.
Okay, I have just one slide left. The team on energy wanted as many angles as possible to study, and that's what I gave them. So this was the basic idea, and this was the wood construction, and it came out and was built last year, and it came out as one public space in the winter landscape, transforming this leftover space into a very popular public space. Thank you.